Okay, so here we are on example 1. Find the scale factor for each pair of similar figures. So number one thing that we have to find is the scale factor. And remember with me, the scale factor is the same term basically as similarity ratio, or when we talk about the side to side ratio. These are all kind of the same idea. All right, and then find the ratio of their, number 2, surface areas. And keep in mind this is the ratio of their surface areas, not their actual surface areas. And then number 3, find the ratio of their volumes. Okay, so number 1, if these two figures are similar, this cube, larger cube on the left, it's not technically a cube because the dimensions are not all the same. So rectangular prism is what this is. So if they're similar, all the sides, all the matchy-matchy sides should all reduce to the same fraction. So it doesn't matter if I pick 20 and 12 or 22 and 13.2, or if I pick 20 and 12, all of those fractions should reduce to the same thing. So I'm going to start with 20 to 12. That's one pair of matchy-matchy sides for my side-to-side ratio, my similarity ratio, and then that would reduce to what? 5 to 3. So that's my similarity ratio. Then find the ratio of the surface areas. Now, here is the magical shortcut. Guys, I don't have to find the surface area of these two rectangular prisms at all, because we know that the side squared compared to side squared ratio is equal to area compared to area ratios. So I don't have to actually compute their surface areas. It doesn't matter if this is surface area or if it's regular area. I just take 5 squared over 3 squared and get 25 to 9. That's it. That's all I got to do. And then for the volume ratios, same thing. I don't have to actually find the volume of each rectangular prism. I now have this fabulous shortcut that says whatever those volumes actually are will reduce to the same ratio of the side cubed to the side cubed. So no, the actual volume is not 5 cubed. The actual volume of the little one is not 3 cubed necessarily, but whatever the ratio is of those two will reduce to 125 to 9. So that's example 1. Okay, so let's go ahead then and take a look at example 2. This is a good old ACT problem. Says the formula for the volume of a sphere with radius r is shown above. We already knew that. That's volume of a sphere. The radius of planet Jupiter is about 11 times the radius of planet Earth. Okay, so just to give us some perspective here, here's Jupiter, here's Earth, Jupiter, Earth, and we could say if it's 11 times, basically if Earth is 1, then Jupiter's radius would be 11. Now, we don't know what Jupiter's radius really is. We don't know what Earth's radius really is. I mean, we could Google it, but what we do know is whatever the ratio is, it reduces to 11 to 1. Okay, so assuming that the planets are perfect spheres, about how many times larger is the volume of Jupiter than the volume of Earth? So we know, since we're talking about volume compared to volume, we know that side cubed, and these are radius, spheres don't technically have sides, cube compared to side cubed equals the volume to volume ratio. So we can say it said how many times the volume of Jupiter than the volume of the Earth. So if we do Jupiter on top and we do bottom, we're talking about 11 cubed to 1 cubed. So 11 cubed is 1,331. 1 cubed is 1. Now, Let's take a look at how I did that. So our answer is C, is because it's 1,331. It didn't say what our units were. Times bigger. So let's look at where to find the cubed button on the calculator though. So to put something cubed in your calculator, there's two different ways to do this. One is, here's 11 and we're doing 11 cubed. This little caret thing, this little rooftop looking button up here, if you press that, whatever comes after that will be an exponent. So it can be any exponent. It can be to the second power, the third power, the fourth power, whatever. I just press 3, and then if I press that right arrow button, it gets me out of that exponent, just like it does on a square root symbol. All right, so that's one option. Another option is if you go to the math button and it's number 3, that does it automatically always to the third power specifically. So I personally like this little rooftop button there because it always works for any exponent, not just for 3. So that's how to do that. All right, then the last problem I think we'll save for another video.